I think we can start. So, yeah. So yesterday we have seen the sets. We also saw the dictionary. Basically, the difference is very simple between set and dictionary. Set has only key, dictionary has key and value. That is how we need to think. Okay. Uh, that's the most important thing. I think from the uh, how the values are stored in the set or in the dictionary. It's all based on the hashing, and there is something called, just for your understanding, I explained this. What is called the modulus operator? How do they do? By using bitwise operations. I hope you understand bitwise operations. Bitwise operations. So you can also check whether the item is there. Coming back to the dictionary, you can also check whether the item is there or not. You can use get. Get would not. If there is no value, get would obviously return none. Don't want to use get, you may face actually the error, so that you have to handle the try catch kind of a try uh, except kind of a key error, and is on some errors. No key found is kind of an error. Isn't visible. Okay, make it right. Okay. So this is what exactly yesterday we were discussing. If you can get a value, we can get a value. If the value is not there, by using get, uh, it gives none. I think 1 minute. Okay. And then you try to get the value by using normal, uh, what do you call, dictionary of the key. Automatically, if the key is not there, you may get a, so you may get a now no key found kind of a value. Sorry, no key found. It would jump to the exception because it raises an exception, so that the exception is handled over here. So like that, actually, you can have dictionaries. You can create a list and then try to find out the number of elements inside the list, etc. Like that, we can do with the basic things. So we see that maybe you may have to work on dictionaries at later point of time. Let's see that, because uh, many things in Python are dictionaries, keys and values. Even the values can be functions as well. It's quite interesting thing. We will discuss those things a little later. But coming back to the basics, so three things we will discuss in this till we reach the until we reach the playwright. Another 3 4 sessions maximum. Number one is we will discuss about object-oriented programming, because that's what you need to know. Object-oriented programming would be everywhere, particularly with respect to Python. Second thing is we'll discuss about multi-threading, and we also discuss about async await kind of things. I'll explain about that. So with these three, you get uh, foundations. From the foundations perspective. Yes, you might be very confident that you know things. Whenever you are using any libraries, whether it's a playwright or not playwright, any libraries you are using, you will be confident enough to understand that. So I just put it as oops, sorry. So I'm in the object oriented. The first thing is you need to understand the difference between class and object. Class is just a classification. Object is something, the real thing, which is stored in the memory. So, for example, I create a class. Let us say that maybe something like a student. I don't want to give anything. I just would like to create a class. Not only class, even if you create if statement, else statement, you don't want to perform any kind of operation. There is a keyword called pass. That means you have created a class. What is called class is called student. What student contains? Students contains as of now nothing. Still, it is a valid class. That means you can create object with student. This is a valid. So you can say S1 is S1 and print S2 is S2. So maybe student 1 and student 2. So there is nothing actually. If you really look at it, there is nothing with respect to student. You have not created anything with respect to student. Still, two objects are created. In fact, S1 and S2 are objects. S1 and S2 are objects. You can also see if S1 equal to S2, print both are equal, for example. So two objects are not equal. The reason is whenever we are considering an object, it gives the memory basically. It's about the memory. There is something called S1 is S2. Still S1 is S2 is also not. Both of them are two different things. So generally, if you want to check, because S1 and S2 are two different objects. Okay. I want to check S1 equal to S2. So how do I want to do whether both the objects are equal or not equal? So there are a couple of things from the JavaScript perspective. It is different from the Java perspective. You have to use something like equals operator. Okay, but here S1 and S2 are objects. So because S1 and S2 are two different objects in memory, whenever you try to perform the equal to operation, you always get as false. The answer is false. Okay. You want to check both of them are same. Probably you can check S1 is S2. You can say both are equal, something like that. Okay. This also check the memories. This also you get as false. For example, if I check like this, S1 equal to S2, both of them are false. Okay. So what you need to do is, if you want to compare the data, just I'm trying to explain. I'm trying to explain whether both of them are equal or not. If you want to compare data, there is some kind of a function. Okay, there is equality. You need to define the equality. You need to define the equality. You need to define the equality. You need to define that equality function. Okay, in order to find that both of them are equal or not. So let me check. You saw this. You understand the reason why this doesn't work. This is false. If you want to know, you can see print of this, and also you can see print of this. You get both of them are false and false because these are not values. These are two objects. Two objects you can perform equal to operator only if you define equality function. Okay, you have to define a special function called equality. So what I do is, for you to understand that equality, class student, I just pass. Instead of pass, what I do is I create a student. You can create a constructor basically. You can create a constructor inside the function. To say that two objects are equal or not, you need to have some value basically. Okay, you need to have some properties. How do you define properties? In a normal programming language, you can define properties something like public int, public string, something like that. In Python, the thing is that the everything is like a key value kind of a thing inside the memory. So what you need to do is you need to create a constructor. Definition of init. Init is going to be a constructor. There is something called self and then name. What is this? What is called self and what is init? Init is a constructor. What is the meaning of constructor? When you create an object called student, self means this object. Self means the current object, which is equal to this keyword in some other program. But in Python, what you need to do is you need to give self for each and every function so that it would act as a method. If you give self, then only it would act as a method. So what I'm doing is I give the name. Where do you get the name is the name goes to, sorry, self dot name equal to name. So what does it mean? A student has a property called name. How do you create the property? Because this is all created inside the dynamically allocated memory. So there is nothing like static allocation. It's not like compile time allocation, nothing like that. Everything is dynamically allocated. So when you create an object, you are telling that create something called name. I'm sorry. So what does it mean is I can create S1 equal to student of name Jitin. You say S2 equal to student of maybe Swati. S3 equal to like that student of something like that. Okay. So like this you get three objects. So you are creating three objects. Each object contains a name. You want a name, not only you want name, you want the age also. You can implement age. You can put age over here. Okay, you say self dot age equal to age. And then when you create age as well. Mine is not 30, that's fine. Okay. You can create like this, something like this. This is how you create properties in Python. Unlike Java, where you create properties like this, int, age, string, name, something like that. This is not going to happen with Python. Self is very important. Every definition, whether this is called as a constructor. Constructor means when you are constructing an object. When you construct object, how do you construct? By passing values. When you pass these values, they go and then sit inside assigned to these variables. These are all called as constructors. Okay. When you create such constructors, you can create objects like this. You can create constructors like that. Then what is going to happen here? I want to check whether S1 equal to S2. So if S1 equal to S2, sorry, both are equal. So I ran it, you didn't get any information. Let me give the second one is also same. You see that you don't get. Why you don't get is just because these are two objects. Two objects are not at all same because they have different addresses. So what you need to do is you need to implement a special function, okay, called equal definition EQ EQ of what you do self, that means the current object, and the next object, other object, which is called other. I just gave a name. And then what you need to return, ultimately equal return true or false. When would they become true? Return self dot name equal to other dot name and self dot age equal to other dot age. So when you return this, it's going to return true. If this is true, same, and this is same, automatically this would become same. So this would become kind of a, you can say kind of a operator overloading in C++. So equal to is an operator, you are trying to implement that particular operator. You see that both of them are equal. Let us say I put Sweta, okay, then they are not equal. You see, you don't get. You can put else print not equal, not equal. What do you get not equal? Sorry. What do you get not equal? Because both of them are the values of S1 and the values of S2 are different. Interestingly, you see. So what I do is both of them are equal. Actually, in fact, both I just put objects are equal. You see that S1. So S1 dot equal. Actually, what would happen is S1 dot equal y dot because of self of other. How actually it is S1 dot equal of S2 dot equal, like something like this. It is equivalent to this. This is equal to this. The whole thing is gonna give you a result, and then so you can put S2 dot I think equal of S3. Sorry, something like that you get. This is what actually it is implemented in a different way. Not implemented is what actually you're getting, but basically something like this gets implemented when you pass like this. S1 dot S equal of S2, and then the result, the whole result, I think you need to do like this. Most probably it should work. Of equal S3. Okay, it is telling not implemented, but actually S1, S2, this way it works. Internally it works. But basically this, if you want to select for one, it's like this. True. This is nothing but this. How does it work? It is equal to is an operator. Internally, it works like an operator. Self means the current object. Other means the object that you pass. Okay, this is how you create a function. Sorry, you create a class. Here you can't do this. But when you create a same class again with a constructor where you create variables and then a function called EQ, You can go and then implement like that. Okay, so it's something like this. Okay, let's go to the next one. Similarly, you understand very well CPR stub of 17 oops operators. I go for something. I'm trying to explain classes. Along with that, I'm trying to explain other things as well. So I create a class called point. So I create a function in it where this is a constructor on the current object. So self, from the self object, I have x comma y. So this is going to give self dot x equal to x and self dot y equal to y. So I create a class called point. There is a constructor called x with us x and y. I'm going to pass these x and y to two different objects, self dot x and then self dot y. Now, obviously, I can create p1 equal to point of 10 comma 20, p2 equal to point of some value comma some value. You can pass like this, 2 points. Now what I want to do is I want to create equal to, so def eq of self comma other. You can give any name, not only other. So return, you have to return true or false. Ultimately, you have to return true or false. So when do you return true? If both x and y are equal from the self and the other object. Return self dot x equal to other dot x and self dot y equal to other dot y. So you got to return. That means if p1 equal to p2, sorry, if p1 equal to p2, print p1 and p2 are same. Else print p1 and p2 are different. So when you run it, p1 and p2 are different. When I try to put both, when I put like this and then I try to run, both of them are same. When how do you get it? Because you have implemented EQ. Now I want to implement P1 add of P2. That means I want to do P3 equal to P1 plus P2. So plus is the operator overloading. How do you implement plus? Print of P3. Unsupported operand on the types point. So what you need to do, you need to implement that. How do you implement? Definition add of self comma other return self self dot x. You need to put self dot x plus Yes, you these things we need to provide in class because these things are operator overloadings. So obviously, you need to provide in class. Yes, you need to provide in class. Oh, there is no other way. Okay. So self dot x plus self dot sorry other dot x comma self dot y plus other dot y. So what I'm trying to do is add function is going to add two things and got to return the third thing. You see that you got the result as P3. You want to know what P3 is? P3 dot x comma P3 dot y. Let me put it as x sorry x equal to and y equal to. So how do you get this? Because you have implemented add. So these are all normal. These are all not normal methods. These are overloaded methods. Remember that these are all overloaded methods. These are not normal methods. These are all these are not normal methods. These are all overloaded methods. What if yeah, so like this? What all you have? You have I think sub. Uh, I think you have sub. You have I think multiplication. There is also there is something called true div or something. True div. It's a true division. You get a true division. Obviously, there is a true div is nothing but this is you know that this one true div is also there, and we have plus equal to operators, which we call it as a I add sorry plus equal to operator. We call it as I add. This is divided by operator. This is obviously the multiplication. So we put it as star. This is a subtract, and you know that there is equal to, there is add, something like this. These are all the things you can do. These are all the operators. You can obviously I minus also there is. Okay, there is also I minus etc. Uh, these are all the operators actually. And so one thing is, what if, see, simple thing, you come here. What if the other is not the point? Other is not a point. Okay, what do I mean by is, this is fine. I do like this. P4 equal to P1 plus 100. It's a pretty tricky thing actually. Because Python is dynamically typed. It is not like Python would check the type and then can perform the operation. Python is dynamically typed. That means the type of a variable in Python would get to know only today when the application is running. It is not like when the application is compiled, only when the application is running. So what happened here? There is a chance that this would lead to error. So you need to check every now and then. That's very important in Python. You see that P1 dot plus 100 is not a operand is not eligible operand. P1 can add only with the P2, which is also of the same type. So what you can do is, whenever you are implementing this, you need to check whether what exactly you are trying to implement. So if not is an operator, is instance of other, is instant of other is point. That means if this is not an instance of the point, this is not the instance of the point, what you are doing is return not implemented. else you return this. So what happen is this is whenever you are trying to return, whenever you are trying to implement this, what would happen is this would lead to not implemented. It's a attribute error, but it is lead to not implemented. Unsupported operand type in a properly it gives type error. It would lead to a type error. This is an attribute error. It's a different thing, but it would lead to a type error. That means both of them are two different types. So how do you handle this? You obviously have to go and then put the try and except block, maybe type error, print some type issue, something like that I put. So this would not crash your application, but this would gracefully return it as an error, some type issue. That means you have to restrict here in Python. That's one of the biggest challenges people face in Python because everywhere, because even here you have to do this here. What if the other is a free variable, right? It's not a type statically typed. It's a free variable. Free variable means any variable you can pass there. It let you pass any kind of variable. So how do you really handle that? We can call it as it's overloading. Basically, these are all overloading. Even though you write a special functions, you can see hyphen hyphen underscore underscore equal underscore underscore add. These are all the special functions. What are these special functions? These special functions are some special representation inside Python. This is a class. You are using this. You are using the instance of the class. Maybe you can write a main function to just to say that it is a main function. You know that how to write. How do you write main function? This is my class, right? This is my class. So what I can do is everything simply I can write if name equal to main, then execute. This is treated as a main function. This is treated as a main function. If there is no main in Python, but still this you can consider it as a main function, like this name equal to main. What some people do is everything they can put into a separate function. I'll tell you. You take everything, you write a function called main, and they just put it as main. People write code like that. People write code like that. Okay. What do they mean? What do they mean? They just write a bit. There is no. We are calling the method called main here. Yeah, yeah, this is a function. I'm sorry, it's not a method. We are calling a function called main, but there is no main like in Java. There is no main like in C language. Okay, Python main is little different. Python main is you are telling your interpreter jump here and start executing. That's what you are doing. It's kind of a jump statement. There is no Python would interpret from line by line. Python, there is nothing called, there is a starting point. There is no starting point in Python. There is no starting point in Python. Python compiles line by line. or interprets line by line. But how do you achieve something called main? There is no main in Python, yet you can achieve something called main. It's a built-in variable. Okay, it's a built-in variable. What we call it as it's a built-in variable. So what it does, name equal to main, it would give you something called true. That's all. If this is true, that's all. This is true, so it would go and then execute. There is nothing called some people write name equal to script. You import a script. Okay, you can import a script. For example, you can say name equal to script. You execute. So main is a built-in variable value. Name is a built-in variable. Main is a built-in value. Where do you get all these variables and values? When you print global, when you print local and all, you get this. These are already created. Print globals. Okay, print locals, something like this. If you do in Python, we get it. Okay, it's a function. I'm sorry. So what these locals and globals? Locals and globals are functions. What these functions contains, they have some kind of predefined things in Python. None is something called cached is none. Okay, you can see main. Name is main. It's a predefined. You see that this is a dictionary. Inside the dictionary, name is main. Doc is none. Package is none. Loader is this loader. Okay, these are all predefined. You don't need to really worry about what is this. You don't need to worry. These are all already there. It's already there in Python. These are all predefined. Okay, in Python. So like that, we get to know what is called main. This is already there in Python. By the time you run your application itself, Python has something like this. So you are checking name equal to main. This is only the syntax that you have to use, something like a compiled programming language. Name equal to main. I think we discussed this earlier as well, but just trying to explain once again. Okay, so let's go to another class. So for your clarity, so this is a constructor. Inside the constructor only you need to create variables. Actually, we don't call them as variables, we call them as attributes. X and Y are attributes. When they are called, whenever you create the point, it is not like your other programming languages where class student or class point where float x and then float y. It is not like this in Python. In Python, you need to create attributes to the object. When do you create? When you create an object. When you create an object called point, you put the bracket. The moment you put the bracket, okay, automatically whatever you pass here, those become attributes. What you pass whatever you give to the object. What you pass is whatever you pass to the object. Okay, that's what you need to do in Python. Okay, Python is very tricky thing if you are from the different programming. For example, let me go to another object. So let's talk about constructors. 18. Let's talk about oops constructors. 18. I go here. So what I do is I create a class student. I create a constructor. Inside the constructor, obviously I have to write self. That means name. I can also give default values. So self dot name equal to name and self dot age equal to age. You see this, we create a student which has got name, who has got name and age. If you don't give, let's say S1 equal to students, S1 equal to student of name Jitin, or maybe S2 equal to S3 equal to student of age 43. You see that three objects. Print S1, print S2, print S3. I'm sorry, I think it would print the Python dot name comma S1 dot age, S2 dot name, sorry, S2 dot name comma S2 dot age, S3 dot name comma S3 dot age. You see that unknown and zero because I didn't give anything. Zitin comma zero because I gave only the name but not age. Unknown and 43 because I did not give the name but I gave the age so that I got it as 43. Something like that it worked. The way how it worked is like that. So you can also create a constructor with the default arguments. That is possible in Python. Okay. These are all the default arguments. That means if you don't give any argument, you can consider as a default value. Like that, you can create. But one thing is, default arguments must come after the non-default arguments. That's very, very important in Python. You cannot create like this. Let's say that I'll create same thing here. Again, I create something here. I want to create name. I want to create name. I want to create name and then I create age. This is considered wrong. The reason is this is considered wrong. The default arguments, the default arguments, the default arguments should come after non-default arguments. Either you make everything as default because if age is there, name is there. Name you can give unknown, but age cannot. Then what you do? You copy here, you mark it like sorry, you mark it like this. But what you need to do is you have to give like this. So this should come to the end. This you can give, but this you cannot give. The default argument should come after non-default argument. That means the default argument should come after non-default. That means this is non-default. So this should come after this, but not this way around. This is fine. Whenever you create age, you must give the age. Obviously, it would give some kind of errors over here because you must give age because age is not a default argument. I give age. Here also you should give age. It would understand, and then here you give age. There is no problem. Or you can also give name. This is fine. You can give like this. I think why it is not taken. I have not printed. I think I'm not printing this. Let me go and print. I'm sorry for that. You can see Jiten, Jiten and unknown because this is unknown. This is unknown. So whenever you give arguments, these are very, very important thing in Python. Default argument, non-default argument. These are all very important thing in Python. Okay, very important things in Python. Okay, so init is a constructor. Defaults like a normal function init. For example, you want to create even init inside a. For example, one more thing. I want to create init. Uh, there's a bad idea as well. I'll tell you. For example, creating a list from a class. Okay, I want to create a list. For example, let me put it as a dynamic defaults or something. I want to create a list. What I do is uh, class my list is the class. I create definition in it and all I give self and then I pass items equal to this. So you can pass items, but this is not a good idea. Okay, this is not a good idea. If you don't pass items, this is not a good idea. What you do is because these are all the default mutable, you know that list is a mutable object. This mutable object is passed across multiple methods, multiple instances. Okay, default mutable objects are passed across multiple instances. It's very uh, bad idea. Instead of that, what you need to do is you give items equal to none rather than that. And then what you do is if items is none, when the items is none, you put items equal to empty. Okay. Otherwise, self dot items equal to items. Something like that you need to write properly. So giving always something called none. If the items is none, that means you don't pass any items. You give it as in because this items is mutable across the entire uh, system, right? The entire object. That's very, very important in order to do. So what you do, I create my list. So my list equal to my list and all you create. So what would happen? What does the my list contains? My list contains nothing. So print my list dot items. You see that the items would be nil. I'm not saying you cannot give empty here. You can give, but that is not a good idea. If you don't pass anything, just give it as a none. Keep it as none. It's always good to give none as the. Let us say my list equal to my list of items. Maybe I give it as 1, 2, 3, 4, 5. My list dot items. So here you are passing some list. So when some list is there, automatically it is not none, so that it would go and then assign the items to that particular list. When you go there, you get the items. So whenever you create other let's say that I create a function. Let's say def sum of self comma and all. So what I do, sum equal to 0, and then what I do for I in items, sum plus equal to I, return sum. So what items? Self dot items. So items is an attribute which is within the object. So sum of, for example, if I create a function called sum of is going to take the object and then give you the sum of the items. So how do you do? Because it is none, we are going to give properly. So here print sum equal to mylist dot sum of. Similarly here mylist dot sum of. When you run this, here you got 0 and then here you got 15. So 5 plus 4 9, 9 plus 3 12, 12 plus 2 14 plus 1 15. So you got 15. Something like that. You can implement these methods, right? You can implement these methods. For example, I want to know maximum number. Definition max self. I want to get the maximum number. So max equal to, maybe if the list is if the length of self dot items is greater than 0, what I do is max, I create a variable called max equal to self dot items of 0, and then what I do is for I in self dot items, and then if I is greater than max equal to I and all, and ultimately after the loop I return, sorry, after this, so if greater than, for example, I'm sorry, if less than 0 or less than or equal to 0, I return 0. Otherwise, I take this, after that return max. So I return max. I get the maximum number, max of self. So when I take a list, my list equal to my list of some values, I get sum of, I get max. When you run it, this is the sum and this is the maximum value. You see that this is the maximum value. Now it could be the second value is the maximum value. What if I create a max of for this, let's say max of for this, because the list is nil here. So whenever there is nothing, I give max as 0, sum as 0. Max as 0 is also not correct, actually not implemented, something like that you need to return, but fine. So this is how you have to create classes. You need to create methods. As of now, you need to create methods. Okay. Let's say definition. What is, you see, return my list. This is quite a different thing. Definition is what actually, but this is a different thing. You would see that. What is called? What is it? It's a my list. I may put as class my list. but there is no self here. So you cannot call it as mylist dot what. So I call it, you cannot call, because this is not a mylist. It is called mylist dot, because it's not a method. Why it is not a method? You did not put self here. Since you did not put self here, this is not a method. It's going to return. So I put print line, print of this. It's not a method. You see, class mylist. It's a class level function. There is no static functions or something in Python, at least here. This is a class level function. This is a method. How it is a method? There is a self. If there is no self, it would become a class level function. Class level function, you call it as with the class name, not with the object name. These kind of things you understand. You see, lot of things are there in Python. So many things are there in Python. We will learn, because unless until you really go through that, there are unless until you really go through it, it is not easy. I'm not saying it's difficult, but a lot is there in Python. Okay, we will go through that as much as we can. Uh, we just started object-oriented programming today. We'll see how best we can do. Okay, that's all for now. Any questions you do ask? Otherwise, we will continue tomorrow.